All right. Wait, am I live? I think so. It's been a minute. It's been a minute, hasn't it? Actually, you know what? Not all my lights are on. Let me fix that. I'll be right back. I know, I just started. I'll be right back, though. Hold, please. All right. The location has changed, hasn't it? 1 second. I was looking a little blue. That looks much better. It's a little dark on the one side. I really need that one light, which is packed. I don't have it. How am I going to fix this? I need a little fill. I look like a Batman villain. I'm just thinking really quickly if there's something I can easily do to fix this. I was like, nah, I don't need that fill light. I'll survive without it, but I really am quite dark over on this side. I was very upfront. I wasn't moving. I just moved my family 250 miles. Now, what did happen, while you see like the one side of my face is really dark, is I did pack my fill light, which I thought I could get away with, but this was looking kind of harsh. Not gonna lie. I'll be moving in a month or two. I'm just staying behind to fix up the house, and there's two big things my house needs: baseboards. And you're like, whose house doesn't have a baseboard? Well, I remodeled the whole thing, but people lived in it before I got the baseboards in. And so it's very hard to install baseboards while people are living in your house. And then the flooring in the upstairs just needs replaced. I did hardwoods on everything else. And so I just need to do that. There's some like miscellaneous other things. I'm patching some drywall holes, but the reason those two big things, it's hard to do those when there's people in the house. That's like the key thing, is like it's hard to do those when things are sitting on the floor. So 250 miles is quite a distance. You're right. They're really close to their grandmother and grandfather. And by really close, I mean like next door, for these 2 months. That was one of the things. My kids haven't gotten to grow up around family. And, my parents are getting older, so I wanted to get a little bit closer to them. This is very close. It won't be where we end up being, but yeah. Yeah, so I mean, it will be. I plan on driving up some weekends, like after the Saturday stream, driving up and hanging out with them on Sunday. And they're coming back here for some little, just a couple times. So yeah, I don't know. I don't know if this is a good way to move or a horrible way to move. I don't know. I'll let you know in 2 months. I'll let you know in 2 months. Actually, you'll be along for the ride. You'll get to see it. I need to find a fill light though. This is atrocious. I look like a Batman villain. I don't sound like a Batman villain, but especially when I look this way. I guess that's when I see it. When I look straight, I can't see myself, but I think it's not as bad. It's giving me eye strain, but I think this isn't as bad. I couldn't think of what to put, Dutch. Like I have a few things that I want to get done, but I don't have a program for today. I'm just back. I've been doing a ton of stuff. I do want to go over the null cloud architecture because I got time to think about it. Feel like a Batman villain. I actually have this work light, and I'm wondering if I put it on the turn it on the other side of the room, if it will be calm enough by the time it get. You know, I'm gonna try that really quickly. 1 second.
I'm back. How's everyone doing? This looks better, yeah.
I was going for the robot. That's the only voice filter I have on command, okay? So I was going for a voice filter. That's the only one that I've programmed in yet so far. So you know what? That's Batman's new villain, is a robot. I'm calling it. There's going to be a new Batman movie. Robot. It's not perfect, but I'll play around with it before next stream. I guess, which is tomorrow. Maybe I'll play around with it before Saturday stream. I might play around with it next. Yeah. All right, but I think it's good enough. It's not perfect, but we'll live. We'll live. Okay, one thing that I need to fix first is my i3 is messed up because I guess the monitors got plugged in the wrong way, and then I updated it, and then I replugged the monitors in the right way, and now I have to undo my update. So I need to do that really quickly. So I'm on like I'm on a table instead of my nice standing desk. So like I had to take because I packed my desk. So I had to like take everything down and replug everything in. It was a nightmare. That's not working. Why is that not working? 1 second. I have no idea why that wasn't working. All right. I just turned it off and turned it back on. It works. How are you doing these days, Dutch? I haven't gotten to talk to you recently. This cord is routed weirdly. Getting to write that fantastic C# these days. Dutch, I think I have something that's going to bring a smile to your face. I think you're the only person on right now. So I'm going to tell you, I'm not going to spoil it for everyone else. So I've done some honest ads on my YouTube channel, and I have 2 in the works. One is an honest ad. The other one is an honest documentary. It's an honest documentary. It's a mockumentary. I get it. Not really mockumentary. It's supposed to be satire. I'm not mocking things. I'm actually trying to call out legitimate problems I see in the industry, and just have fun. Try to help people have fun and not take themselves too seriously on their favorite thing. Anyways, it's literally an honest ad, full stack. A full stack. Not honest ad, but an honest documentary, full stack. I think you'll like it. I'm having a lot of fun with it. Absolutely. I think you'll like it. All right, let's see. Can I just undo? Let's see. I'm just gonna try to undo. Me being dumb. Let's see. We'll just delete these. This might be good. Dutch, this is like the whole parody that I'm spinning. And I'm getting some interviews by people as well. Like I'm making it like a documentary, or trying my best to do it like that. So yeah. Anyways. All right, did that fix everything? Let's see. Really? Yeah, okay. Cool. That did fix stuff. Now we have like 9 is not supposed to be on this screen. So we've got to fix that. Let's jump this over to the terminal, which is on another screen right now. Let's let's jump this over to 2, since 2 is currently on this screen. We need to get to 10 over here so that we can put the monitor on 10. 1 second. We're just reorganizing screens. Now we can go to 1 over here. Oh, beautiful. 1 is over here now. 6 is where it's supposed to be. All right. I think we're cooking with rocket fuel. All right. Okay. Now we're we have, my tabs are back where they're supposed to be. All right, let's talk about I didn't post in Discord. Let me do that right now. So people know I'm back. I want to talk about the null cloud. I had some time driving a truck, unloading a truck, generally sweating in the real world. And I was thinking, I also got into a Twitter argument. I can pull that up. Let me cone of silence this just to make sure. I got into a Twitter argument, which, I've never really been a Twitterer, but yeah, how do I find what I don't tweet much. And when I do, I'm just basically having fun. But I made one tweet that I thought was worth talking about. How do I see my stuff? My tweets. Oh, I have to like go to my thing. Okay. Okay. Yeah, we'll follow this Twitter thread. Cool. Let me tell Discord I'm back. All right. There, that's done. We're going to talk about that. We're going to open up some stuff so we can talk about it and write some stuff down. I think I've been looking at the null cloud incorrectly. And not entirely. Like my goal, I think is correct. I think my biggest incorrect thing was I was trying to build it on top of stuff that already existed. And I had some plans for some of the lower level things. But the thing is, nothing I would bring without that lower level stuff was really that much better than what already existed. And, I want to be somewhat innovative if I can. And that was kind of eating me up. It was kind of eating me up. Where is my... Here, we'll get some music going. Wait, I don't hear any music. I see it here. I think you guys are getting the music. I think you guys are getting... I am not getting the music. What have I done? Well, Dutch, stick around. Make an honest ad with me. It won't help your resume. I have destroyed my resume by doing this. Okay, so why can't I hear the music? I am genuinely upset about this. Do I need to flip around the plugs? Did I plug the Mac into the PC one and the PC into the Mac one? Maybe I did. 1 second. Don't worry. I'm just a little dented. I can hear it now. Okay. Don't worry. The universe is correct. I am wrong. Okay. Sorry about that. All right. We were opening up Obsidian so we can document some stuff. Oh no, not my honest AI ad. You guys didn't see that. That was not a live stream leak. Okay. I'm definitely not making an honest AI ad. That's there just to make you think I might be making one. Well, I'm sorry, Dutch. Right now is a tough time. And I want to be helping people. I feel like I'm not helping people very much. I feel like I should be helping people more. And I don't know that I have been. All right. So we can kind of talk about the Null Cloud. So this one is the honest AI ad is going to take me a little bit of time. I am literally trying to recreate like those main stage presentations and make fun of what all of the companies do in a satirical way that's not also specifically calling out a company. It's gonna be either my greatest masterpiece or what makes it so that I'll never get a job again. One, maybe both, possibly both, but one or the other. All right. The farmer has been replaced. It's on Steam. I mean, I shudder to, oh gosh, to think about Python, running Python on my machine. I'm just not sure I have enough cores for that. Oh wait, it's single threaded. Doesn't matter. I'm sorry, I couldn't help myself. All right, we're good here. We're gonna actually just make a new, we want this one, but we also want a new folder. Why? It's changing. We're gonna do stuff there. Is the music level good? Or should it be a little bit louder, a little bit softer? Okay. All right, I'm not gonna make this a video right now. We're gonna have to work through some stuff before I make it like one of my null bytes. I'm gonna have to, we're gonna have to work through, but I want to go through my thought process, what caused this to happen, and just give you guys some of the things that I'm gonna work through over the next couple weeks. I'm gonna work through it online. We're gonna be diagramming, we're gonna be chatting about stuff, we're gonna be writing some code to test some stuff. We're gonna look at what was originally Legion, what its goal was, what it's going to have to kind of morph to do and whatnot. So let's talk about the goal of the Null Cloud. Well, the goal of the Null Cloud was to basically make it where you think about your application and none of the infrastructure. And I still am going for that goal. The goal hasn't changed. So the goal hasn't changed at all. I want it to still be the same thing. We're gonna just let this open up here really quickly. You can all friend me. Doesn't matter, I won't play with you, but you can friend me if you like. Wait, what is it called? The farmer has been replaced. Is this a real thing? This is not a real thing. You lied to me. The farmer was replaced. This actually looks kind of fun. We might do a stream of this. This looks kind of fun. This is almost like that elevator game we played where you had to program the elevator to pick up people. We might do a stream of this because this would be a fun stream. How long is it? Like, what type of challenge? Does it take people like 8 hours to solve the entire thing? Two-hour speed runs? Ugh. That feels like a first time through. It might be difficult to... it might be... I'll think about it. I'll think about it. But I'll buy it and we'll do a stream of it. Maybe next week. All right. So we'll do this though. I will add this to add to cart. Boom. There, it's in my cart. Okay, I'm gonna get rid of this though. For now, we're gonna talk about this, but we'll do a stream of it next week. Possibly the week after, but we'll see how we go. All right, so Dane, it's good to see you. It is good to see you. And Twitch alerts are broken right now because we had a power outage for like 2 hours. So there you go. It is always you. It is always you that it's broken on, Dane. I am so sorry. You are one of my best supporters. I'm giving you that shout out right now. You're one of my best supporters, and Twitch alerts are always broken for specifically you. And I'm sorry. We'll fix that. I'm sorry, Dane. All right. I do super appreciate it though. All right. So we're just talking about, last week I had off. I say off. I'm super exhausted because I was moving. Now, you might say that it looks the same, and it mostly is. I'm in the basement of a completely empty house, which is interesting. Now, my children are actually coming down to visit me next week. But I'm staying in the empty house to fix it up. So anyways, that being said, there are still, I'm still in the old house. It's still the same good internet. So I haven't moved just yet, but I had some time to think, and I thought about the Null Cloud. Now, I made this tweet, and we're going to go over this tweet. Someone please explain to me, like I was 5, how Kubernetes changed anything about the way we actually manage infrastructure. Because I hear that statement all the time, that Kubernetes lets you think about infrastructure differently. And I've really actually contended that this is a myth. And after arguing with these two people, I contend that it's still a myth and absolutely is not a thing. And if you guys want a little null byte on that, we can make that video because I do think it's a myth. And I'll get into that during this breakdown as we go through it. So that being said, what is the null cloud and why does this actually pertain to the null cloud? Well, the null cloud, as somebody aptly put it in Discord, and I'm so stealing them for marketing, Dane is now head of marketing. The null cloud is designed to be cloudless. It's meant to be cloudless. So what do I mean by cloudless? There's no good cloudless solution. There's no good solution that just works outside of the clouds. And as you'll go through and see here, everybody here is talking about using Kubernetes in a cloud, which actually means that the clouds let you think about infrastructure differently, not Kubernetes. They effectively admit that in their retort of my comebacks on the things is that, well, without the clouds, it doesn't actually let you think about infrastructure differently, which then I would contend means that the clouds let you think about infrastructure differently, which is kind of true. But they only let you think about their clouds differently, their infrastructure differently. And part of the thing with the null cloud is you should get to think about your infrastructure differently. You know, my initial thought is to run the null cloud myself, and I do want to still do that. But the whole idea is that you could run the null cloud on your servers and fall over onto my servers if you had too much demand, wanted skunkwork projects or things like that, where you don't have to perfectly predict all of the resource you need, but you'd still be able to have your own infrastructure. I didn't say there was no solution that works outside the clouds. I said that the way it lets you think about infrastructure differently is specifically tied to the clouds. Now, like I said, we'll get into that. We'll get into the tweets, but I'm circling back to what the null cloud was originally meant to do. Absolutely, Dutch. This is the thing that I always go back to, and I appreciate that Kubernetes doesn't manage infrastructure at all. It orchestrates your application. And so when I see this, Kubernetes changed anything about the way you manage infrastructure, and where people are like, it lets you think about infrastructure differently, it doesn't. It doesn't change anything about the infrastructure. It doesn't manage infrastructure. So anyways, all of that aside, this got me thinking a lot about what I was doing. And the thing is, what I do isn't really that special. And if you want to say that there's infrastructure management platforms built on top of Kubernetes, that's fine. But that's not inherent to Kubernetes. You could make it for anything. Docker Swarm, you could make it for VMs. VMware literally has this thing for just VMs outside of Kubernetes. So like, that's fine. That's fine. But it's not indicative of Kubernetes. Right. Yes, Dutch. It's an abstraction for containerization and networking of those containerized applications. Or more simply, it's just orchestrating your process in sandboxes, in these isolated sandboxes, and networking them together. That's what its big focus is on. Right. We could talk about the isolated and why gvisor exists, and it doesn't matter. Now, let's talk about okay, so let's talk about, so the whole idea behind the null cloud was basically serverless, but serverless done in, I don't like the term serverless. What I wanted you to be able to do was write your application and just think about your application, not the infrastructure that it ran on. And I wanted to manage this stuff silently for you completely. I also wanted to manage all of the other infrastructurist like things like databases silently for you. And I realize that databases aren't quite infrastructure in the canonical term of it, but a lot of people would think about like those machines and provisioning them and getting all this stuff to run as part of that, like your Kafka pipelines as well. Again, not the canonical infrastructure, but I wanted to manage some of that, you know, extra infrastructure for you all. Now, what I was doing, and I think that this was a mistake, and what we're going to probably do is we're going to finish making the proof of concept work. The proof of concept actually works now. The UI just isn't fully fleshed out for it. It is basically what we have here right now. We have Kubernetes running. We have gvisor running here on top of some framework motherboards. And basically we have just a couple of services. We have an API service. We have a workload runner that takes your workload, the spec for it, and runs it somewhere in the Kubernetes cluster. We have a container builder that actually takes your GitHub project and builds the container of it that is sent to the workload runner. And we have a UI and basically where your workload runs. It's fairly simple. I say fairly simple. There's a lot of moving parts, but it's fairly simple. These are the parts that I have written. There's also Kpack sitting back here that we leverage. Kpack is running. There's a couple other things that are running in this cluster that we don't actually program, but we leverage. Anyways. But then what I realized is like, this isn't any better than AWS Fargate. I had kind of, the only difference between this and AWS Fargate was this allowed you to just point to a repo and I would build it. And Fargate doesn't quite do that, but there's a lot of really good infrastructure as code to deal with that. So I wasn't providing anything better, anything more innovative. I was building a basically slightly nicer AWS Fargate. And I was kind of sad about that. Like, that's not what I set out to do. I set out to try to be as revolutionary on the idea of running your application. Maybe not as revolutionary because I could think of some really crazy things, but my goal was to think better. Not better, but just innovate. And this doesn't feel innovative. I've proven that we can do this. We can spin this up right now on my local computer and we can get this working. We can build it and we can have it deploy an application. Now, there's definitely a lot of like hardening that needs to happen where like, oh, there could be errors. And if there's errors, it kind of just falls on its face right now. And that's fine. But the concept works as it is. And it's not innovative. So let's talk about what struck me. So here we must, we'll ignore this one. I got a little. Never, as your argument, this is a terrible argument, and I'm just, never say, you obviously haven't used it, that's why you disagree with me. I don't think that's a very fair argument. I think we can disagree and have both used the same thing. But okay, so we can go through and look through some of these things. So adds a container-centric abstraction on top of VMs or bare metal, provides a standard abstraction to facilitate portability, raises the bar on high availability by automating common lifecycle operations, raises the bar on extensible API. And then that's where I followed up and said, okay, this is my point. It doesn't manage the infrastructure. It's an abstraction over infrastructure that is managed elsewhere via some other way, either your cloud provider, bare metal, etc. And that's where then I guess I'm just quibbling over the meaning of the word infrastructure. And I don't think that this is a fair take because, well, if we say that infrastructure means nothing, if your argument is that there's no definition of the word infrastructure, then it means nothing. And then Kubernetes manages your infrastructure. If it means nothing, then it means nothing, and stop trying to explain to me why it means something, because then the whole argument is useless. Words have meanings, and we should strive to understand them. Okay, so this got me thinking. this doesn't manage infrastructure. I'm just doing it all manually. I'm going and I'm updating these frameworks once a month, which isn't even good. Once a month, I go and do sudo apt update on them because they're running Ubuntu server. Nothing innovative there. I'm running K0s to update my Kubernetes cluster. I do this about once every 6 months, which is also not very good. Nothing innovative there. And then I'm running this, which is a slightly better Fargate, which is nothing innovative. Again, good learning. We've gotten to do some stuff. It's been fun. But that's not what we set out to do. Now, I've always talked about a project I have called Legion, mainly just because of We Are Legion. I was trying to make it that there's like no limit to its scaling. A future highway. You should be doing the honest ads. Your sarcasm is on point. All right. So, all of that being said, I kind of was... I had a lot of time to think as I was moving. Whether it was driving a truck, whether it was loading a truck, whether it was unloading a truck, I had a lot of time to think. And my thought was, I don't love what I've created. This is why I haven't even, partially because also people complain so much about Go, and it made me hurt to open up Go. But on top of that, the whole stack was just kind of like, I was making a slightly better Fargate, not innovative. So what are we doing different? Okay. We're actually going to start work on Legion in earnest. I didn't do this originally because Legion is going to take time. Legion is without you guys being able to use it. The cool thing about what we've done so far is that the majority of this was done in 2 months. The majority of this was done in 2 months. That's not going to be true anymore. But we're going to try to actually innovate on some of this stuff. So, we have nodes. And if we're providing a actual cloudless architecture, we'll say this is a node. First, we need a node management layer. This is what I currently call Legion. And then we need something that runs on this. Now, I say this, but we could split this. We could take the Linux principle. We could take, this is where I haven't fully figured out exactly what but I'm explaining my thought process to you guys here. We could then take the node management layer and then put a orchestration layer. An orchestration layer. And then we need the basically backend as a service. Which is Eddington. That's the thing that provides this easy whatnot. Now, the interesting concept, we have basically two competing ideas here, and I actually have two competing ideas here, is we take this, and I'll say this is the Unix approach. So this is the Unix approach here. And then the other one is what I'm going to call the Apple approach. All right. And there's ways to make this approach suck less. And I'm going to talk about that in a second. So this is like do one thing and do one thing well. We build 3 different things and they could be built to work together. That's fine. But we build 3 different things that don't necessarily need each other, really shouldn't need each other, shouldn't depend on each other. And they should do their thing and do it well. Or we take what I would consider like the Apple approach where, and what I'd love for this, and the reason I'm even contemplating this, is to make infrastructure management easy. What do we need to do? I'd love to see if I can't get a single binary install. Basically, one of the problems we falter with is the huge, overwhelming complexity of managing everything. Dirk, what's up? Eagle 11, it's good to see you. You know, Eagle 11 is the only one that came to my house and helped me pack it. You didn't get a plane ticket? That's right, you didn't. I think he actually is the only one that knows where I actually live in this chat. Hopefully. I don't know about you all. Sometimes you worry me. I hope he's the only one that knows where I actually live. Yeah. Knowing you guys, I absolutely do not want you to know where I live. False hope is good hope. Okay, let's get back on topic. All right, so thanks, Grey Hatter. So these were my thoughts that I was going through while moving. Now, what are our goals? Our goals is to keep it simple. Stupid. Yeah. Keep it simple. So I want this to be as simple as possible. Now, what I'm going to say is any project that's taking on this is going to have some amount of complexity. If you're handling orchestration and node management, there is going to be some level of complexity. But with everything we do, with every we make, we need to ask ourselves, simplest. We need to ask ourselves, is this the simplest way? Now, there's going to be 2 competing ideas here, the simplest and scale. So what we're going to do is basically, a lot of the times if you get into the low level performance, you might have to do something a little bit complicated to get better scale. Something, a really easy thing that we can point to is cluster management. So cluster management, we're going to handle with a basic swim algorithm. We're going to handle with just a really simple swim algorithm. Now, a simple swim algorithm is going to be stupid simple and actually pretty easy to implement. The thing is, a stupid swim algorithm doesn't scale well on its own. Don't get me wrong, we're going to get a few thousand nodes out of a standard swim algorithm, but it should handle millions of nodes. This has been documented and is possible. You just have to do extra things. It becomes more complicated. You have to do, nearest neighbor algorithms. You have to do not random. You have to do things like this. And so this is where, like, at the beginning, we're going to stick with simple over scalability. We could spend a year creating an algorithm to do clustering that is super scalable and have only that at the end of our year. So first will be Kiss, then it will be scale. Kiss, then scale. That's what we're going to do. So I'm just going to put that right here. Kiss, then scale. Okay. There is a folder named blockchain. I actually love blockchain. Okay. I do like blockchain. I think that it's cool. Now, I say that. The reason I don't talk about blockchain more than I do is every application that I've seen that people are talking about are scams mostly. So, I don't talk about it much. The problems that they solve, the cryptography and stuff is very cool. I like it. The actual concept of consensus in an unknown format, like I actually think those things are really interesting, how they solve them. Now, what real world problem do we solve? Well, Git is about the only, anyways, that's a sidetrack. I do like blockchain, but I also don't like what people do with it. So I don't talk about it much. Anyways, okay. So the first thing that we're going to do is we're going to keep it simple, stupid. We're gonna make it, we're gonna take the simple, and then we'll worry about scaling later. Again, I'm not saying to make bad decisions now or things that won't scale or things like that. No, I'm saying make informed things and say, hey, we can make a stupid, simple swim algorithm in a week, maybe 2 weeks if we really take our time at it, and it will scale fine for the time being. And then there's actually known ways to, or we could innovate and make a better way, or we could make an entirely different clustering algorithm. But as long as we separate the clustering algorithm out into its own thing, we can do it any way that we want, and we can worry about scaling that to more than a couple thousand later. All right, so first thing is Kiss. We want it to be as simple as possible. This is why I think the single binary install is so important. All right, so the other thing is, in all of this, I want people to be able to think about infrastructure differently. I actually want this to be true. I want people to be able to think, obviously, infrastructure is infrastructure, and it's there. But what if, this is the real kicker. What if we could manage infra with GitOps? I mean bare metal infra. I don't mean cloud infra, because you can do that. I mean, what if your bare metal could be managed this way? When you have an update, so this is my current thinking. When we go to update these nodes with new versions of the things that the stuff running on it, we check in a commit. And Legion rolls that out systematically for you. That's kind of the way where I'm going. What if it doesn't have to be something virtual on top? Dutch, I'm asking you to think outside the box, okay? Throw away constraints. Kubernetes doesn't manage the node. Kubernetes doesn't even manage itself. This is the node. If you run privilege, you can add. It doesn't though, does it? Like I said, I didn't say that there couldn't be something built on top of Kubernetes that does this. I said Kubernetes doesn't do this. Sure you did, Dutch, and that's fine. Kubernetes doesn't do it. Absolutely, Dutch. Sure, it does the rollout. Sure, that's fine. But it doesn't give you an API to manage the machine, does it? So this is basically giving you an API to manage the machine. That's layer one. Layer 2 is the orchestration, which is allowing you to run these sandbox things. This is kind of what Legion was originally, basically a better Kubernetes. I don't love Kubernetes is too complicated for its own socks. And we can get into why I think that, but there shouldn't be a control plane. We don't need a control plane. I think that's antiquated thinking. You don't need these 3 special nodes, these 5 special nodes. We don't need those. It's easy to get rid of. Every install should be of this orchestration layer should be a single binary. Kubernetes, it's 20 binaries, and they all have to be installed differently on different nodes if they're a control plane node or a worker node. And even on the worker node, it's not a single install either, because there's actually other stuff to be installed there too. So now, don't get me wrong. With this orchestration layer, we are trying to solve the same problem as Kubernetes. 100%. Trying to solve the same problem. We should try to do it in an innovative way. A way that's better. Oxide kind of does this, but it's only for their machines. Future Highway, yes. If you buy Oxide, they do give you a way to do it with their machines. So what is there on these nodes? Well, the minimum is kernels and software. What software? Well, there's all of this. So minimum requirement, if it's running containers, is something to run containers. Then there's something to run Wasm. And then there's something to run VMs. You know, there's probably also stuff to do SSL. You know, we can talk about what is needed on these machines at a high level. You know, there's obviously the other software that's like either Legion or Maestro. Then you have the kernel. You have everything on top of that that you want on those nodes. Yeah. Dirk Ickles, have I heard the good news of Nix? I have. So NixOS doesn't provide you the API that I was looking at a high level because they have no idea about clustering, right? So Nix doesn't provide all of this, but I actually would leverage concepts from Nix for sure. Yeah. I mean, absolutely. So you have Maestro, you have Legion, you have possibly Eddington. Now, Eddington's probably running the orchestration layer. So that's probably not actually updated by the nodes, the node management. So it'd be these types of things that are being updated by this API. Can I build the cluster? Possibly. Well, I'm not sitting here telling you that I've thought of everything yet. I'm sitting here telling you guys that I had this revelation after this argument that this was like what was really lacking in the space. We don't have a revolutionary way to actually manage nodes. You know, if we're talking about some of the things that are influencing me right now on this piece here. So if you want to know like the projects that are influencing me here, there's a couple. NixOS is actually one of them. Not the top one. The top one actually is a project called Bottle Rocket. Bottle Rocket actually provides some of what I'm thinking of here. It doesn't actually provide the clustering, so it's not exactly what we need here. But Bottle Rocket has a pretty cool idea of having a management management API that allows you to actually manage a snapshotted write OS. So basically, or a read-only OS. So basically, updates are full volume swaps. So basically, when you go to update this, there's a partition that's running and there's a partition that isn't running. And when you go to update, all that happens is there's a partition swap. They write the new OS here, and then, you know, it's a reboot into the new partition. If something goes wrong, you fail back. I like that. And so we're going to steal that from Bottle Rocket. The configuration management, I do actually like. I don't know whether we build it straight on top of NixOS yet, or we just take the concepts from it. I'm probably indifferent at this point, but yeah. Anyways, so I like that. I like GitOps. And so what would I like? I would like to see GitOps, this API, be able to actually, you should be able to leverage it without GitOps, but you should also be able to point this thing to a Git repo and manage it that way, where you're checking those files in. And this should all be part of this. You shouldn't have to run something else on top of it. You know, I was thinking like Argo CD is really cool, but then part of me was like, this should just be part of Kubernetes. Not that you have to leverage it, but if you wanted to leverage it, it should just work. And it doesn't. Has automatic updates. Dirk, I don't know enough. I wasn't saying not Nix. I was just saying like I liked the parts that I know of Nix. I just don't know. I haven't dug into it. I haven't done any research on this. I hadn't been thinking about this up until last week. So you're getting some pretty raw. I had a long trip. I couldn't Google because I was driving a semi. Let me tell you, 30 some feet long is long. For those of you who don't understand feet, it was 26 feet plus the cab. I think it was like 34 feet, 2 meters. Yeah, about 10 meters. It's pretty long. And it was 9 feet wide, 9 feet. So about, almost 3 meters. What? Big. It was big. So anyways, just had some time to think, but I couldn't Google. Yeah, Dane. Yeah, Dane. It's a miserable drive, especially because I got the distinct pleasure of driving this truck through Cincinnati and Columbus. These are two very large cities. So do you know what? You want to know the funny thing is? The small town that I went to, which I'm not telling you guys that small town, but the small town that I went to, because unfortunately it's a small enough town, like probably finding me there wouldn't be difficult. The small town that I went to, was more painful than Cincinnati. Columbus was the worst by far. Columbus is a disaster. But the small town that I went to was the second worst because it was small roads that were never meant to have something large run on them. It was terrifying. Dutch, you're going to be visiting a lot of small towns in the east, especially if you do the east of the U.S. Dane, I was so furious. I was like, I'm super smart. I'm checking this ahead of time to make sure that I fit through. And what does Google do? What does Google do? It friggin' blurred the sign with the height of the bridge. Google didn't respond to me. Didn't respond. This sign, for all of you that don't know, tells you the height of the bridge. Oh yeah, I know the road's on there. This is not where we're living. Go for it. Go for Marietta Road. This was me bypassing a big city, so go drive down Marietta Road. Go for it. No, I didn't. No, I didn't. This isn't even close. This is like 3 hours away from the destination, so go for it. Go sit on Marietta Road. Oh. Okay, good point, Dutch. Good point. It narrowed it by about 3,000 miles. You know what? I bet you there's a bunch of Marietta roads. I bet you there's a bunch of. I'm not gonna go search for them right now, but anyways, it's far away. I actually thought about that before I posted it because I was like, and then I checked and I was like, 3 hours is a pretty good circumference. So, anyways, okay, back on track. Back on track. Before we get back on track, do you know? I do know of the bridge that. Yes, I do know it. This is why I specifically tried to map any non-interstate roads. I tried to map. I tried to be like, oh, I'm going to go through here. I went through on Google Maps and walked through them to see if there was bridges and crap. And then the weird thing is they didn't actually blur out most signs. Just that one for some reason. On both sides. I just had to, go and be prepared to back up. And Google Maps never responded to me. It's an outrage. Outrage. All right. All right. Okay, so these are kind of some of the things that I like that I'd like to implement here. For infrastructure, I mean actual bare metal infrastructure. We can talk about how we're going to do clustering and how we're going to do those types of things and whatnot. I'm happy to investigate NixOS. If we can make NixOS work, that would be great. Now, my gut reaction to NixOS is this. Boys. Buse? I don't know how to pronounce this, but it's bring your own OS. I feel like, let me show you this. About a year ago, I don't want this. I want the GitHub. I was going to say, not that I actually have a problem with Nix, but if it forces it, I feel like it gets a little bit more difficult. So one of the cool things here that Bottle Rocket does is it basically allows you to bring your own OS. So they actually do some here for you. And I actually did my own. So they actually use Cargo instead of Nix configuration to basically install the different things that they want to install. So this is like the kernel that they want, and this is AWS, so they did this. I actually did one of these for a Raspberry Pi. I did this like a year or two ago. We made a Raspberry Pi one, which was kind of fun. But basically, this is how you include what gets installed on it and whatnot. Now, this is, I would say, is almost a not package because it's ripped down everything except for literally the kernel and the bare minimums that you're doing. This is NixOS, but worse. Yeah. So again, we need to think about it because I feel like there's going to be people that want to run on Red Hat. And there's going to be your Ubuntus. And there's going to be your Debians. And there's going to be your Nixes. And then there's going to be your real experts that are going to go unosed. Unosed, which is what I kind of consider this is an unos. But now, what are we doing? I don't know. I'm not sitting here trying to say this is exactly what we're doing or that I've done the research. I literally am doing, and this is why I said we're not making a bite out of this. I don't know. It wouldn't be a good bite. These are all thoughts. I'm just wanting to have conversations on it. I feel like there's people that are going to want to do this. And for better or for worse, oh, that's not what I wanted to do. I wanted to get rid of. I think it helps adoption if this is a possibility. I think this helps adoption. All right, we can take Red Hat off of there. That I'm fine with. We took Red Hat out. Okay. And like I said, I'm not saying to do this. Not at all. Not at all. But I like the concept. They did some really cool things. One of the things that they did was they actually have this API that I'm talking about. This is not a full-fledged API from my perspective because I want to be able to do it as a cluster, not as an individual node. And for this, it's really just an individual node. They have this API that allows you to have this management API for a node. But this is what I want to do is have this API. And that comes from BottleRocket. I'm not saying implement BottleRocket specifically. I'm saying I'm not so innovative that I'm just coming up with new ideas and I'm trying to give credit to projects, whether we use them verbatim or we use their ideas and build on them. That's what we're going for here. You're getting PTSD from half these binaries? What binaries did we look at? I thought this was very tame. Maybe that's how tainted I am. Yeah, you have the kernel, the IAM authenticator, the CNI plugins, and Kubernetes. I feel like that's really... really straightforward. Yeah, you have to have this installed if you're installing on AWS. I mean, but I get it. But, and the CNI is always rough. But again, this is to work with their stuff. So, all right, orchestration layer. This is what I classically was calling Legion. And the big deal here that I would like to do here is solve the complexity. Kubernetes does this, but I feel like it does it in a really rough way. I don't like the control planes. Control planes are just dumb. They're poop on a stick. Nobody likes them. Nobody likes managing them. Too many binaries. Have you guys ever done Kubernetes the hardest way? Because we can do it on stream if you guys would like. But there's too many binaries to set up and run. From the API server to etcd to the cloud controller manager to the schedulers. I mean, we can just go on. There's so many of these that we can just list out. Too many binaries. So these are a couple of the things. The other thing that I want to do is it be an execution layer. And by that, I mean agnostic to runtime choice. If you guys were here 2 weeks ago, we went through, this was way too close. We went through, for this execution layer, we went through supporting Wasm. If you weren't here, it was great fun. It took a long time. And then All Cloud kind of supports Wasm now, but it does it in a crappy way. It took a ton of work, and I'm not even sure I could support or manage it at this point. It works as it is, but there's a lot of moving pieces. Wasm, VM, container, process should all be the same. They should all be the same. We should build in, and by this, we shouldn't build in support for just these four. What we should do is build in support, basic plugin support for and this actually goes back. Do you guys know what promise theory is? If you don't know what promise theory is, you should get this book called Promise Theory. One second. There we go. Promise Theory, Principles and Applications. I'm super happy that I just had it laying here. I packed most of my books. Okay, I have like 6 books sitting out. But I packed most of them, but I have this one sitting out. Read this book, but Promise Theory is actually going to help us solve this problem really elegantly, I think. Promise Theory is not JavaScript. Or, I mean, you could do it in JavaScript. It's a math. This is a math. This is a math book. This is a math book. Just so we're clear, Promise Theory is a math book, not a computer programming book. But, I mean, it's just a mathematical representation of promises and what you can do with them in complicated systems. Now, again, this looks at the math side of things, but we're going to do the software side of things, the math side. And it's going to be good. It's going to be fun. You're going to have fun, I promise. I promise. I guarantee. It will probably be at my expense, but I guarantee. Okay. So what we need to do is basically have this support where you can support anything. And it's built in where we can support anything. And like I said, we'll use Promise Theory. I already have plans for this. This is the part that I have a little bit more thought out. Is this. So no control plane, single binary, an actual pure execution layer. Some things I haven't thought out Kubernetes operators. Kubernetes operators are really cool. Really cool. Just like really cool. And I don't like how they're implemented. The reason I don't like how they're implemented is because they use the control plane. Use the control plane resources. What if we could make an operator-based framework that was for any application, whether you ran it on here or not? Now, maybe this thing can leverage it and run it better. I don't know, but this is another thing that we need to innovate on. The operator pattern is really cool because it gives you this high availability, the ability to run multiple instances for high availability with a high availability data store that has consensus. So not only do you get consensus, do you get all of these things, durability because it's safe to disk. Not only do you get all of those things, but you get them kind of for free. But you're using the control plane's resources. You make your Kubernetes a mess. So we need to provide Kubernetes operators, but we need to do it in a way that is self-contained somehow. I have ideas on this. And I think if we do it properly, the orchestration layer itself will leverage the same principle. It will be one of these operators running on Legion. That would be the coolest way we could get it done, but we'll see. We'll see if that happens. So this is kind of my complaints with Kubernetes. What component is doing the operator piece? It would be Maestro or Legion, depending on whether we break these out into two things or one thing. Like I said, these could be one thing, they could be two things, or we could go full Apple and make them all one thing. Like, I think that this is pretty cool because, like, the thing is, we could make them three pieces and then we could bundle them as one binary somehow. So we could maybe do both because I feel like there's people that would want pieces of it. Like maybe they want these two pieces, but they don't want the backend as a service, the actual Eddington part. And they just want, they have their own data center and they want the amazing orchestration that Maestro provides. And so they just want to run these two things. So I think maybe we do both. We make them as individual parts. This is kind of where I'm going here, but have some way to make it a single binary install to do the full Eddington null cloud stack. The operators don't update the infer. And promise theory. It's math. Sorry, that was a terrible comeback, but promise theory. Math is scary. I promise you, promise theory deals with it. I need to go get a drink. I'm going to run really quickly to grab a drink. I'm going to play an ad while we're doing it because we're like 5 minutes from an ad. So I'm going to go do that. And then I'll be right back with a drink. All right. All right. Math is scary? No, math is fun. Math is fun. Let's see if ChatGPT can do something fun. I hate AI so much. My goodness. All right. Sorry, Now, I have a question. Does anybody want to join me for the next AI games? I actually have a really fun idea, but it requires live participation. I'm glad you can see how this is going to solve infrastructure. Okay. Now, I just want you guys to see this, okay? We have this. We have all these things. And I know that you guys think math is scary. M-A-T-H, okay? But I don't know if you guys have ever read the book. There's a book called The Hitchhiker's Guide to the Galaxy. If you're a younger person, don't read it. If you're an older person, you need to read it to understand this. The Hitchhiker's Guide to the Galaxy. If you don't understand that, what you get here is 20 plus 1, okay? Or I'm sorry, 13 plus 1 plus 20 plus 8 equals 42. So, in fact, I have just proven to you that math is the answer to everything. Okay? So don't let it scare you. It's the answer. So when you have a hard problem, the answer is probably in math. I'm sorry. I couldn't help myself. If you have a hard problem, the answer is math. Dutch, that's my whole point. How is this, you asked, how is this helping us solve our infrastructure problems? And I'm saying if you have a hard problem, the answer is math. We will use math, like promise theory, to solve these hard problems, right? Well, you know what? ZP is also the an answer to stuff, okay? Fair. Fair, I hate you. But you're wrong. You're just wrong. ZP isn't a word, probably. But 42 does not equal math. No, what is 42 in ANSI? I don't know. I'm not gonna do that. All right. Okay, so thoughts so far. Are we talking about JavaScript math? Oh no. Oh no. How are you doing, Sergeant Pepper? It's been a little while. You're not wrong, Dutch. You're not wrong. Okay. This is what I'm thinking so far. Oh, awesome, Sergeant Pepper. I know I've been gone for a week, and I know you said something about it. And yeah. Later, Dane. That's really awesome, Sergeant Pepper. It's really awesome that you're getting to write in Rust. Like, that has to be a joy. Oh, Dirk. Thank you so much. The Twitch alerts are down because we lost power this morning for a couple of hours. And while everything has battery backup, the battery backup lasts minutes. It probably lasts a half hour, but maybe 15 minutes, but not nearly long enough. So I'm sorry I didn't boot him. I will boot him up. Thank you so much, Dirk. Thank you, Dirk, and both Dirk and Dane. Well, Dane subbed, Dirk gifted the community a sub. Thank you so much. I have battery backups because it's me. Our power is fairly stable, actually. I mean, I say fairly stable, but I mean fairly stable compared to West Coast. We have maybe a brownout every 6 months, and then we have outages during storms, or when people do stupid stuff like and by that I mean there was the outage today was because there was a construction crew that hit something. That's when we have outages. Dutch, you wish you were just kidding. So yeah, no. The East Coast power is fairly stable at least where I'm at. But You'll get in shape that way, Dutch. That's for sure. All right. That leaves the backend as a service, like the Eddington part, kind of as an enigma. I know we haven't talked about it a lot, but I think that it could change quite a bit based off of this layer here. And I only say that because instead of like Kubernetes and operators and stuff, we'll have this thing that is operator-like, operator-esque, and I'm not sure exactly what that will mean yet. It should be better, whatever we do. I don't know what better means yet. Like, I actually love Kubernetes operators, and the only thing that I really dislike about them is that they are actually leveraging your control plane. So it's not like a very portable solution. I almost think that this thing here should live outside of this layer. I'm not sure. We need to think on it. I want a general purpose operator framework. And I don't want it just to be calling an API that provides it for you, right? I'm not sure. I need to be thinking about this. Originally, I thought about providing it the same way Kubernetes does, just allowing you to hit its API. But then I thought that that's kind of gross. Something's going to need to look at the operator and force it. Yes. Again, this goes back to the promise theory, which goes back to math being the answer. You know what? I'm going to do a video on promise theory. Let's get that in the books. Do I have promise theory is a distributed system. We'll do a promise theory, and I'll talk about what promise theory is, and I'll like try to summarize. It's not really that hard. It's not that hard, and I'll try to come up with some like concrete examples of how we're going to leverage it for orchestration. Right, Dutch. I think that's what I want to do. I think that basically this orchestration layer basically is going to have some sort of thing that allows you to stand up, some sort of HA consensus storage, some sort of Raft-esque like thing, but for your operator, of effectively making this like a deployment for your thing. Not Raft, probably. I was just using etcd and Raft. Probably this is going to be Paxos. OmniPaxos. Probably is going to be based off OmniPaxos. That's the kind of running theory, at least. What do I call a collection of rafts? A shipwreck. A trash. I just always thought that when there was a shipwreck, you'd have a collection of rafts going out. But I guess I'm wrong. All right. I think that's really it here. This is just what I was thinking over the weekend. I actually want to innovate. I don't want to just be another crappy serverless. Apollo, thank you for your riffraff. Thank you. We needed that. The other thing that you know what would be fun to do here. All right, and this is for pure learning. Pure learning. And, I don't know if it would be good or not, but one thing that I'd like to do in this orchestration layer this is going to surprise all of you. All right. So I actually think that there's some cool applications of machine learning. Okay. I actually think with orchestration, and so I look at this from the statistical analysis side. What we have is really cool statistical analysis. And it is actually really cool. And I think building that into something that orchestrates is possibly really cool. I've been thinking about it for like auto scaling and stuff, because a lot of the times when you see scale, things that need to scale, you'll have something like this. And, this might be midnight. And this might be, 5 p.m. or something. I don't know. You could have traffic that looks like this. And the thing is, you might need to start scaling right here. Need to start scaling here. Because if you start scaling after the fact, if your scale is lagging, you'll get crappy service. So you kind of need to scale ahead of your actual usage curve. And so building in something that could continually watch your traffic and do this preemptive scaling. I'm going to actually make this green. So we'll do this. Let's see. Something that would be able to handle this automatically for your orchestration would be super cool. Now, I don't know that this needs to be built into the base layer. I think this could be one of those operators that sits on top of it. This could be like an AI deployment. In Kubernetes where you have the Kubernetes deployment, there could be like a deployment dash AI, and like this is what it tries to do. I think that this could be really powerful. Now, the place where it is really stupid is it'd have to collect this data before it could do it. So you'd almost need a way to run it manually first and then slowly let the AI take over. I'm not sure yet. Like I said, these are some things that I think would be really cool to add to this. What is Entity Framework? Entity Framework. It is a framework for databases made by Microsoft for the .NET people of the world. Apollo, my Excel is atrocious. This is just me talking and drawing and thinking. This is not a well done one. I do better ones. I hesitate to call it an ORM because Entity Framework does now, and I'm not an expert on Entity Framework, so maybe it's just an ORM. But in the little that I've seen of it and talked about it and talked to other people that use it extensively, it's more than just an ORM. Yeah, Dutch is maybe good one to ask about it. Not me. I personally don't like ORMs. I can do a video on it. Merrick is not a fan of ORMs. I'm not a fan of ORMs, actually. It's weird, I know. ORMs every single time. Okay, Sergeant Pepper put it perfectly. Okay, I'm going to actually correct Sergeant Pepper. ORMs are very leaky abstractions. No matter how good the ORM is, I end up inevitably fighting the ORM, writing just SQL myself, or doing crap. And that's generally my thoughts on ORMs. I'm currently learning Fast API and SQL. How would I address DBs? I don't want to learn more abstractions. I prefer to sharpen my current skill set. Okay. I know people that deal with DBs. One of the things is just use it. So any tech that you want to use, just use it. The other thing that I would have to say here, when doing something like this, is specifically when you're learning something, don't use abstractions. If you're using it to learn it, now there might be a time and place for an abstraction over a database or whatnot, and that's fine. But when you're learning it, don't use abstractions. So make a real project and use it. Don't use any abstractions, because the abstractions are you learning the abstraction and not the base concept. Okay, so I'm going to, if you are asking which databases I think are good, there are two SQL that you should learn right away. SQLite and Postgres. There is MySQL, but this is more dead in the water than Red Hat. I don't really tend to recommend it. You could talk about MariaDB as kind of the open source offshoot of MySQL, but I just actually prefer Postgres. I think Postgres is a better database in general. It has more features. The features usually work better, and I actually really like Postgres. Wait, what did I say? I said MariaDB, didn't I? Did I say something else? I might have said something else. I didn't know how to spell it, but that's what I'm talking about. Oh, did I say Miria? My bad. I meant this. So basically, when Oracle took over MySQL, there was a group of people that split to keep it free. It doesn't really keep up with Postgres, in my opinion. It's fine to learn. I have no problem if you want to go learn this because you want to. I'm giving you my opinions here. Take them with a grain of salt. If I was going to do a SQL database, I would learn these two. So this is my recommendation here. One second. So Chris Killer, there are some intricacies. So like if you're writing pure SQL, you're absolutely right. But then there's always database specific features you can use. There are database specific features like what index you're using. You know, if you go to Postgres, if you don't specify the type of index you want, you will get a B tree. But it has hash indexes, it has gist, it has spgist, it has gin, and it has brin indexes. And so if you start to leverage these, well, you're leveraging something that's more domain to specifically Postgres. If you start to leverage a feature, they have a vector index now as well. So if you're leveraging vector on a portion of your, there are features that are not all the same. Sharding is another big one. I don't like stored procs in general, so I didn't bring up stored procs because of that. Stored procs are very centric to whatever your database is. Sharding is very different depending on which database, but you're probably not learning that right now, and that's fine. Indexes are highly different depending on it. The index and query optimizers are actually different as well. So if you're talking about actual scale, the index optimization, the query optimizer is different on this, and you'll have to learn, if you're really doing these at high scale, how to leverage them appropriately. So anyhow, in general, you write pure SQL, you can swap out the database. It never is actually the true case that you can just do that when you've gotten to production with it, but in theory, you are correct. Now, this is my SQL database recommendation. There are things like time series. We're going to put this in other. We're going to put this in other. So there are other types of databases that... I don't know why it's doing that. So there are other. And so Dutch is right. There's InfluxDB. There is, so, you know, I'm not going to list these, but there's time series databases. There's vector DBs, but I wouldn't actually use a vector database. I can do a thing on that. I actually don't think vector databases are really that. I don't think that there's a reason to have a vector database, and I'm not trying to be difficult. I actually think vector databases are really cool, but it's more of a search algorithm. It's more of a index on a database. This is actually why you'll see that Postgres, if you join in my news tomorrow, you'll see that Postgres actually outperforms Pinecone as a vector database, because it has a vector index. Anyways. So there's time series databases. There's Influx, there's ClickHouse. There's a bunch of ones that we could go through. Although ClickHouse is more of a columnar, but people use it for time series data as well, interestingly enough. So I'm going to leave time series there. It's a little bit niche, but what I did want to go into is there's some other ones. So there's data warehousing. So you have your data warehousing, and your data warehousing is going to be something like your Snowflake. I don't know why I'm blanking, but it's AWS. What is their warehousing one? Oh my goodness, I'm blanking on it. The column based databases here. So these are really big in some data analytics thing. You have your DuckDB. DuckDB is a column based. Kafka is not, right? Kafka is a log based database. But Hadoop is. Good call out on the Hadoop. Hadoop. And AWS has, I'm blanking on it. I shouldn't be. I've actually used it. They're just saying Snowflake, but that's a Redshift. It's Redshift. Ah, I knew that one. Sorry. Okay, Redshift. Aurora is not column based, so I wouldn't call it data warehousing. It's just kind of a wrapper around Postgres. Right. Aurora is just the Postgres knockoff. Yep. Okay, so I'm getting sidetracked here. So I'm sorry. I'm trying to answer. I'm trying to answer Chris Killer's question. Because this all came up because somebody, I actually really dislike this database, and there's these things called document databases. And in this, there's a popular one called MongoDB. SharePoint. Now, well, okay, so don't get me started, Chris Killer, on NoSQL, because I hate the term NoSQL. Because technically, all of these fall under NoSQL. It's a terrible categorization. I absolutely despise it. I could talk for an hour on that alone. I actually would love to get rid of the name NoSQL, because really it's much more specific than that. There is SQL, and then everybody says there's everything else. But as I'm trying to point out here, there are actually categories and they do different things. This and this are not the same, don't do the same thing, and couldn't be coerced to do the same thing. What people use DuckDB, Hadoop, Redshift, Snowflake for, you couldn't use MongoDB to do it. It would be impossible, it would be stupid, and it doesn't make sense. The same with time series databases. There are, from Prometheus to InfluxDB and those, there are time series databases that do a very specific thing that have nothing to do with MongoDB. I really don't like it. Sergeant Pepper, you were the person that got me on this tirade because I really don't like MongoDB. I really, now, I need to state, I state this every single time we have a conversation about databases because I like to be upfront with you guys. I am biased. Now, I do state this with full certainty. MongoDB isn't a competitor of ours. They would have to be good to be a competitor. And I know me saying this means I'll never have a job at MongoDB, and so be it. You can't scale with MongoDB. It like MongoDB is easy and just scales, but it doesn't. And I can tell you painful stories of the but it doesn't. Very painful stories. Also, document databases are kind of a lie. I don't find their usefulness as much as the other ones. And I find that at best, document databases are used alongside these other solutions for basically something that I would leverage S3 for. I want to store this document. It's maybe larger. It maybe has this data. Now, MongoDB does let you search over it, which is kind of convenient, but there's also other ways to search over those things as well in those other things. Shoot, Postgres even has the ability to support JSON, a document DB. We're rounding it out. I'm bringing you to that. We're getting there. We're getting there. I'm running the gauntlet, and I always put other people first because while I'm biased, I'm not here. I'm not sponsored by anybody here. I'm not here to sell you something. 100% not. And I know that the people that have been here for a while know this, but I treat this with a lot of care and respect because I know, how easy it can be to, even if I'm not trying to mislead people. So we'll talk about key value. There's actually a couple key value that we can name off the top of our head. We already mentioned etcd. So we have etcd here. That's a key value database. Now, another one that I know that you guys know that I'm going to talk about is Aerospike. Aerospike, this is the company that I work for. So again, why I'm biased here. These are key value databases. Sergeant Pepper, you are 100% correct and wrong at the same time. Postgres allows you to make joins on the table. And if one of your columns is a document, you can join on all of the columns that you have outside of that document. So if you structure this correctly, you can do it just like you would in MongoDB. I 100% guarantee it. We can do it if you like. It's actually pretty powerful. Plus gives you all of Postgres. Now, to be fair, there's other key values here. So there's Aerospike, there's Foundation, right? Foundation is a key value database. I say there's others, and then I completely blank after Foundation. And it's fine. If you use MongoDB, that's fine. I have no problem. I don't love MongoDB myself. And I consider myself a pretty fair judge because I will recommend these other things. I don't just sit here and shill for Aerospike. I tell people to start here. If you're just learning, start here. Learn SQL, learn SQLite and Postgres really well. Learn these. Do that well, and that will serve you so much. You can do so much leveraging just this. It's not even funny. So if you want to start your education, start here. That's fair, Sergeant Pepper. That's fair. Redis is a good key value. Redis is a good key value store. DynamoDB is a document, right? DynamoDB. Dutch, you're just saying stuff that doesn't go in the category. Can you put aerospace? I'm never going to live aerospace down, am I? Absolutely not. Absolutely not. I'm never going to live aerospace down, am I? Both at work and now on stream. I get aerospace. Freaking aerospace. Aerospice, even better. So this is actually a really good point of these here. They're kind of a key value store. Aerospike, now not necessarily Redis, but Aerospike can do 95% of what MongoDB can do. Plus it can do more. Redis is the same. Redis can do maybe 85%. And then Redis has like some really cool things. Like, to be fair, it has its channels that you can do. Channels, which are actually pretty super cool. Aerospike has maybe the most scaling vector search of any vector. Of any database out there. So this is where the plus comes on these two, is they can do Mongo things plus more. And etcd, Dutch is not wrong. We could put POSIX. There we go. Minus. Yeah, etcd can just compact and lose its crap. It's fantastic. I hate etcd. Windows registry. Okay, yeah. Windows registry. Absolutely. Okay, so this goes back to learning. I'm sorry, we got distracted. If I was learning... Oh, good point. We'll put keyval up here. I'm not typing anymore because it would change where all my arrows were drawn. And so I don't want to do that. So keyval is up here now. All right. So if we're talking about learning, this is what I recommend. Number one, learn SQLite, learn Postgres, learn those two, and learn them well. Do them well. Now, when you go for number two, this depends on what you want to do. If you're talking about large scale things, so if you're talking about, let's say you want to get into a place where you're deploying on Kubernetes, you're probably going to want to go here as number two. You're probably going to want to go to some time series, some log Not log-based database, but database is designed to hold logs and things like that, other time series data. So you're probably going to want to look here. So, you know, you have, I didn't do this very well. There's Influx, there's Prometheus. I didn't do this because I have no idea how to spell Prometheus. That's not how you spell it. Prometheus. There's this one I'm going to put in here. I'm going to put ClickHouse here. House, even though ClickHouse can kind of bridge these two, can be both of these. ClickHouse is really cool. We got to check it out one of these streams. Now, if you want to go into big data, if you want to go into big data analytics, you're going to want to go here for number 2. You're going to want to learn here for number 2, because this is where data is stored. If you're talking about massive amounts of analytical data, it's in one of these. If you're wanting to go machine learning, you want to go here. This would be your number 2, because this is where your vector databases are going to live. If you're wanting to go into massive real-time data, you want to go here. So you're talking about, you know, really big, like Aerospike. I can just talk about this from personal experience. The big things that they're in is I'm sorry, ad tech. But they're also big in security, because if you want to provide real-time security analysis on something, you need massive amounts of data and you need it real time. So there are banks that protect your credit card based off of this massive amount of data, and they need it in real time. When that credit card gets swiped, that chip gets read, the phone thing does its phone thing. You want to know that that's a correct charge as fast as possible. And that's where these really big real-time databases come in. And they are really powerful at it. So yeah, machine learning, real-time data needs. So fraud. The reason that ad tech is so big into this real time is because you actually can lose serving the ad if you don't serve the ad fast enough. And so there's actually a big demand to serve the ad really fast, or else you just don't get your ads served. So yeah. Elasticsearch is a good one. So real time is a very interesting question, Gray Hatter. What do you call real time? What is real time? This is a good question. And then the second one I'll pose to you is nearline. Nearline. Half a second is, so for me, as I generally do it, I say less than a millisecond. So you need to be less than. I didn't leave enough room. You need to be less than 1 millisecond. If you're less than 1 millisecond, in my opinion, you're close enough to real time to be real time. So yeah. Aerospike, for example, can maintain less than 1 millisecond at a petabyte of data. Now, maybe that's not near fast enough for you, but that is what it is. No, gaming isn't nearly real time. Not nearly. Yeah. Okay, so this is actually a really good question here. When I say that Aerospike can do this in less than a millisecond, let's talk about that. Because if your computer is sitting here, and the Aerospike server is sitting here in a data center, and you send a request through the cloud to this server, I don't care if it's in the same city as you, it's going to be 50 milliseconds before you get a response. And that's if it's going fast. Okay? Small payload. Shoot, if we ping Google, Ping has no payload. And you're talking Google has servers here in my city. You're talking 30 milliseconds to do nothing. The server has no work to do. It doesn't have anything to find. It's spending no time on their servers. It's hitting their edge servers and responding. And there's zero payload sent back, nothing. It takes 30 seconds. So this is a very realistic thing. So when I say that Aerospike can serve this in a millisecond, I mean that when the server gets the response, it responds in less than a millisecond with the data that you're asking for. Ping does not have a reply payload. It does not, does it? Maybe it does. Oh, you're right. I was not thinking about it. It's super small. My point stands. It's one of the smallest payloads you're going to have. It's an insignificant payload. I was incorrect though. You're right. It does for sure have the ICMP in there, but I'm sorry. I misspoke. An insignificant payload that you're making. Okay, so when I say near real time, I'm talking less than a millisecond. Now, I also use the term near line, and in this, I mean less than 50 to 100 milliseconds. I'm a lot looser on this, the near line, because I use this for terms like Kafka. And when I say Kafka, I really mean like event-driven architectures. So we'll say like, so in event-driven architectures, you don't make a call and get a response. You don't do this. This doesn't. No. We're going here. You don't do this. What happens is there's an event, and that event does a thing, and then that raises another event, and it's slower than direct communication. So when I'm talking about those type, the event-driven, and maybe this is a bad term for it, this near line, it's what the industry uses most of the time, I think, is this event-driven architecture, which again is a bit slower than if you just did a request and a response back. That's generally what I talk about. I'm the only mod. Nobody wants to mod my community for free. I don't have mods. No, Grey Hatter. I'm sorry. I'm sorry. There are like 3 people that I love having in the community. Definitely don't want them to be a mod. Right. I love you too, Grey Hatter. Duchess, another one. No, I would make Dirk. Dirk would take it seriously. Although, Dutch, you'd probably get banned. Dutch, you don't want Dirk to be a moderator. Oh, Grey Hatter is 2 of them. Oh, gosh. All right. What do I think about Fast API? Oh, okay. You'd ban straight for Mongo disparaging. All right. What do I think about Fast API? Let me tell you what I think about Fast API. The words high performance and Python is illegal to be in the same sentence. The words high performance and Python should be illegal. When you vote for me for president, that's the freedom of speech I'm taking away. Look, I want to encourage you to learn. And if you're just getting started, Chris Killer, if you're just getting started and Python is your jam, you go for it. And if you want to use Fast API, you do it. If this encourages, if this lets you get and do what you want to do, you go for it. Okay? I don't want to discourage you. And if you're learning, that's awesome. That's awesome. If you're talking about production APIs, I would not have Fast API anywhere close to anything production. Okay? And by production, I mean, I do a lot of code for enterprise customers. So production to me means a lot different than production to somebody that does like Twitch alerts, like my Twitch alerts that are currently broken. And so I don't want to discourage you with anything I say right now to go out there and learn. And if Fast API is the thing that you want to do, you do it. Wait, Facebook doesn't use Django. We'll ask ChatGPT. Instagram was Django? Okay. Instagram wasn't originally created by them, right? Capability snob. I appreciate that you say if you can't make your Python fast, it's a skill issue. I appreciate you saying that. I see you there on YouTube. Welcome. I disagree, but welcome. You're allowed to disagree here. Yeah, they bought Instagram. I'm pretty sure of that. Okay, yeah, everybody's agreeing with that. Okay. I don't follow social medias very well, as you probably all know. I don't have a Facebook service, but I could not imagine Facebook running all of Facebook onto Django. But so Apollo and capability snob. Everybody's probably right that you can get fast-ish. But I would also argue probably not, actually. So obviously this is what is this? The computer language benchmarking games. Let's see, where is it? Let's we can look through all of these. Where's the actual website? This is not the website. This is just talking about it. Where the crap is it? There we go. There we go. It's not good if you go look at it. And I realize that there's always a grain of salt. There's always a grain of salt. And it beats Java. That's great. At some things. Maybe not many things. What the garbage? You say that it's just a wrapper, but my point is, it doesn't feel like a good C wrapper. Doesn't feel like a good C wrapper. Capability snob. That's an interesting take. Every performance problem I've had in a production system, Java, C#, Go, Python, has been less likely in Python because it would have used better database APIs. Now, you know what? I don't want to get into this argument because I was actually trying to talk to Kill Chris. Sorry, I keep forgetting your name. Sorry. Hang around a little bit. Be a regular. I'll remember your name better. I don't want to get into the weeds with this, but there's other reasons I wouldn't have Python touch my production services. It's very difficult to prove that your Python is correct. Duck typing is a scourge of this earth. And I know that there's new modern ways to get around duck typing, but you're getting around the language. You're not actually leveraging the language. If you're making an argument that the APIs to databases are better and that's why Python is better, there's plenty of good API libraries for databases. You know, duck typing is garbage, Grey Hatter. And your take is a trash take. There you go. You know, if you want to talk about that the APIs are better, that doesn't make sense to me because our Python is just a wrapper of our C. So our C library has a better API than our Python. And actually, they're all now going to use the Rust library. So our Rust library will actually have the best API and everybody else is just a wrapper. So if your statement is Python's better because its libraries are better, I doubt that too. Anyways, if you want to learn programming, pick whichever language you want, though. Don't let that deter you. I don't like Python, and I especially don't like it in production, but it's fine if you want to use it. I also don't like Fast API. If you're wanting to learn about making a REST API, though, you could do worse. Go ahead and make it in that. I think what I want to say most is don't worry. Yeah. Except I can't type it for some reason. Don't worry. Because the thing is, the experience. I could talk to you for a while about why duck typing makes it very hard to know if your application actually does what it's supposed to do, and how that can cause crashing and it's not fail fast, and why fail fast is good. I could sit here and tell you all these things, but the reason I can tell you these things is I did all these things. I learned those lessons, and I'm happy to sit here and help you learn those lessons together. That's what I want to do here, is help us all level up, and why we do those things, and why I have the opinions that I do. Why do I not write services with Python? Well, it's because I like my applications to fail as fast as possible. Rust and Go gives me really good ways of validating that my service is correct. Now, you can do that with Python as well. You can run a bunch of different linters that try to make the same thing that's just naturally built into Rust, and that's fine if you want to do that. If the syntax of white space mattering in a language is good to you, take it and run with it. Everything else is just experience, so don't worry and just go build stuff. This is going to be your best learning tool there is. It's just go build stuff. I'm gonna call you Snob. I'm gonna call you Snob. It's your name, not mine. It's just easier to say. There's a lot that goes into how many requests a service can handle and how much throughput. It has a lot to do with what they're doing and how they're doing it. It's very difficult unless of all of these services do the exact same thing. It's very difficult to compare one to one. Oh. Somebody's getting timed out. All right. Let's not get into a language war. I'm being serious. I'm so tired of it. I am. Let's not get into that. Go to somebody else's channel to argue about what language you like. The most common source of slowness I have seen is a round-trip database latency. Snob, I agree. Bad database queries, bad database design, bad app design, all of those, I think, are 100% things that cause slowness before a language does, especially in a large distributed system. 100% agree with you. 100%. That will shoot you in the foot before the language does. So, Chris Killer, that goes to history. Do you know how I was talking about how I learned? I learned by doing this, by building stuff. And when I built stuff, I made mistakes. Right? So when you do this, you will come up with things that you think are good that aren't. And if you're looking at this, I'm planning on doing some of those with the null cloud. We're going to try some ridiculous things and try to actually innovate in this space. And that's what we were talking about. Now, along the way, we're going to do stuff that doesn't work out. And what we're going to have to do is look at it and say, that's a learning experience. This sucks because of X, Y, Z. Now, one mistake, and I am going to call it a mistake, was duck typing. What we found out with duck typing, and the big problem that people have with it, is that when you dynamically type something, it's almost impossible to prove if it's right. Let me show you an example. Let me show you an example. Let's go to NullDB. So we can go in here, and this is the database we wrote on stream to talk about consensus and other stuff. But we can go in here and we can open up any one of these, and let's do something kind of crazy. Let my age equal 76. And we're going to make this mutable. Now, we're going to ignore this error. We're going to ignore this error, but this is another thing that is a fail fast. It expected 3 arguments, only found 2. Cool. We're failing fast. This compiler, this thing is failing as fast as it possibly can. It's saying, I can't even compile because this doesn't work. And we can go then look here and see that this, but let's continue on. Let's say further down here, I want to let my age equals 43. Okay. Now this works. That's pretty good. Now that's because it's the same type, but actually we can get rid of this because it's immutable. Anyways, the problem with duck typing though goes, you can go my age equals 78 and do this, and it's not going to let you do this. It might actually be complaining because of this. 1 second. Let's just comment this out. Oh my gosh. Okay, here we go. We got it past that. So now it's telling me right now that these two things aren't compatible. And this is actually really important because what happens is it can be very hard. So in Python, an integer is not the same thing as a string. And it can be very difficult with duck typing to know if you have the same thing. So this would work in Python, and this would actually make my age a string. But if you used my age in something that expected an integer, and I'm making this very simple, it would crash. But it wouldn't crash until runtime because it doesn't know the type until it's running. And this is why a lot of almost everything that you see is moving away from this, and why things like Python and JavaScript are getting things to enforce or at least hint at what the type is. Yes, I know for anybody that's more Experience, you're going to say that this was very simplistic. I was trying to keep it simplistic. That was the whole point in the idea. Did I? A Snob said a good type system is better than a poor type system, but no type system is a lot nicer than a poor quality type system if you have a good domain model. I'd have to think about that, Snob. I'd have to think about that. All right, everyone. I was actually attempting to help Kill Chris understand the concept. You can talk about naming variables all you like. Kill Chris, yeah, well, YouTube chat is actually being more productive at this point. Kill Chris, ignore Dutch and Grey Hatter. I'm being serious. Because what they're doing is arguing about the naming of variables, which doesn't matter because it was an example to prove or show you why people walk or don't like that type of system and what we've learned over the time. Now, you can choose to not learn that and bicker about that, but that wasn't the point. Can they see our chat? Hopefully not. Hopefully YouTube doesn't see your chat. They must be big Uncle Bob fans. Thank you, Chris Killer. I actually don't know Uncle Bob's takes. I know that I don't know. I'll have to read some of his stuff. Oh, he's the Tom Cruise of Java programmers? That's amazing. I'm going to have to look into some of his stuff. You guys all know how much I love Java. You know what the worst thing is? It's not even Java that I dislike. It's just the design patterns of Java, which if that's Uncle Bob, Uncle Tom, if that's Unkies, I'm just going to call him Unky. Uncle Bob, I probably dislike it. If that's, I don't write code like Java people do. The language could be amazing. I just don't write code the same way they do. So yes, what we were originally talking about before we got sidetracked was if you were learning, what I would recommend as far as databases and what order. I know that I have 3 twos, so I wouldn't learn document databases. This is like a -1. Like, learn document databases if you have to, and then move on with your life. Do something better with it. But I also put some examples. This wasn't meant to be an exhaustive list of these things, but my recommendation and all I was giving Chris Killer was that I would learn SQLite, Postgres, and the whole SQL, like pure actual SQL. Don't use our ORMs, so don't use abstractions. If you're learning it, abstractions are killing you because you're learning the abstraction and not the thing. And the best way to learn it is just to make a project. So come up with an actual project. I don't mean a to-do app. I mean an actual project and use it. If it's a to-do app, that's fine. Actually, that's fine. But make a real app and use it. Learn these two first. These are like your foundational databases. Then, depending on what you're interested in, move on to these other databases. So, Influx, Prometheus, ClickHouse, these are kind of your, I said other instead of time series because ClickHouse is not time series, but these two are time series, and ClickHouse is kind of a multi-database model database. We can get into it. And it was my recommendation to get into these three if you were looking in like a distributed application development, because time series is really big there for storing time series database, and ClickHouse for some data warehousing of logs and stuff is actually a known use as well. So these are really good as a secondary one once you know SQLite and Postgres really well. But if you wanted to get into really big data and data analytics, then these were your data warehousing ones that you can get into. There's DuckDB, which is a columnar, Hadoop, Redshift, Snowflake. I don't have a big take on which one's the best one. Pick which one you want to use, whether it's Snowflake or DuckDB. I've actually heard good things about DuckDB and bad things. It was super unstable for a little while. But supposedly it's becoming more stable with version 1, so maybe give it a try, but it is what it is. ClickHouse is also can be a column-based database, so ClickHouse could be in that as well, but that's if you wanted to learn about big data warehousing. Don't learn document databases. Just do the world a favor and don't do it. Don't do it. And then if you're learning key value stores, really there's two really big ones. There's KeyVal and there's Aerospike. Really foundation, etcd, Windows registry. Windows registry is also a key value store. I don't recommend learning these. Foundation is probably fine. I don't know that a lot of people use it. Probably not worth learning. etcd is only important if you're in Kubernetes. So if you want to manage Kubernetes, learn etcd. Otherwise, don't learn it. That's about it. I should probably make a actual null byte about this, like an actual clip on this. This just came up because Chris Killer asked about it. And so I just kind of rambled some stuff. Maybe I should make a video on it. I could do a little bit better. But yeah, Snob, that's what I was talking about. I'm getting much better about avoiding chat. Think about that, chat. Think about that. I put you in the corner. All right. All right. I don't know. I've never played with it either, Snob. The Atomic is not something that I got to play around with a whole lot. All right, rest of chat. We're going to see how long Dutch stops talking to himself. We're going to see how long it takes. We're going to see how long it takes. It'll be good. Cypher, what's up? Cypher, you're not supposed to be talking to Dutch. He was in the corner. Dutch is in the corner right now. Dutch, you don't even write a language that Duck types. You liar. You liar. All right. That's probably it for me tonight. Oh, JavaScript. We all write JavaScript. We all are forced to write JavaScript or transpile something into JavaScript. HTMX will solve it. That's right. HTMX is going to solve our... No, it doesn't. I hate to break it to you. I've been using HTMX heavily. It does not solve our problems. Yeah, well, Chris Killer, I appreciate actual questions. My goal and hope here is to help us all learn. It's to help us all level up, get better, and be able to get a better job and provide for ourselves and our family. So that's my goal. So if you want to come here and ask real questions that I can answer, that I have the knowledge to answer, or at least can give you some insight into, I'm happy to. If you come here and ask me how to render a 3D polygon onto the screen, I will point you to another stream. I won't know. Maybe we'll learn, but I don't know right now. And some streams, today I'm back after a week of being gone, moving. I was wanting to hang out. Sometimes I have things that I specifically want to get done, and if we're doing those things, I might not have the time to go on a tangent of what database is best, but I'm glad that I did have the time. It's a interesting thing. Using Rust, how would I render a 3D one second. Polygon of a horse? It's cheating. Bevy is cheating. Without Bevy. Come on. No. I just want to do it like right raw, straight to the screen. Yeah, let's do it with Vulkan. Capability snob. This is actually probably my biggest issue. Wow, this is a lot. This is a lot. All right. That's actually one of my biggest issues with my YouTube videos. Like my graphics on my YouTube videos are just not like this chart took me a long time to render. And so like I just don't have that nice finish. I really need to find somebody to edit my videos. Oh, Bevy did it in 3 lines. I asked it to do it without the framework, right? So capability snob, ask it to do it for Python without using a framework. Then come back to me. Aw. Aw. Rendering a 3D polygon of a horse using Vulkan and Rust is a more advanced task due to... Thank you for warning. That's why I asked you. Why is win it? You horse renderer. I almost guarantee this code doesn't work. I used my last credits on generating a 3D horse. 100% it doesn't work. I can't believe this works, so it probably doesn't work. Yeah, I struggle, my videos, I struggle doing UI stuff. And that's like the biggest thing that I need to like actually end up doing for these. Yeah, you know, because I get like, I don't know, I mostly don't, but I need like some graphics because like the best I do is like this, where I like show stuff, but I need some like actual physical graphics like on the screen to like animate and do stuff instead of like, I put some text on the screen and this is dumb. I don't love it. What's very clickbaity? Oh, the HTMX? Thank you. I can screenshot. I have it built into my see, I just took this as a screenshot. I guess it has more tools. Oh, maybe this would be useful. If it works with i3. Yeah, I'll look into it. I'll look into it. Revideo? What's revideo? Oh, I know. I actually played with this. Maybe that's what. Maybe I'll do a stream where I try to generate some of these. So I didn't use this. I did use a Remotion. I tried Remotion. I think. I tried this. I didn't love this. Which seems similar to this. Now, Revideo looks to be this actually looks to be stealing this other guy's work. Actually, this looks up like a straight theft of Motion Canvas. This guy created Motion Canvas, Make Scene 2D, which looks like this. And he did these yields. I think these Revideo people just stole Motion Canvas. Oh, it is a fork from... Okay. So they did. Okay. Okay, I'm not sure if I need this. I mean, I'll just use Motion Canvas. Because I just need to make motion, like animated things and then put them in the videos, right? All of this is a whole lot of work. I don't know. I gotta think about it. I gotta get better motion graphics in my real YouTube videos. Like, they're just bad. And I feel bad because I put a lot of work into those videos. And they just don't do as well as if I would actually put some motion graphics into them. See you, Cypher. We'll do a stream. We'll programmatically work for some of these. I also tried what is that one math YouTuber who made one? It's a Python library. Manum. Yeah. I tried Manum as well. Like, the problem I have is I don't love any of the languages these are built in. Like, I don't love Python or JavaScript. And so, like, I don't love investing a ton of time. And then, even then, like, the animations are, like, super long scripts. So, like, it's a ton of work to make them. I don't know. Three brown, one blue, or 3 blue, 1 brown. Yeah. I like his math videos. One of my favorite YouTubers. I wish I had MATLAB, but more MATLAB. You said MATLAB, but it's MATLAB. I don't own it though. And I don't love RStudio. I need to figure it out. I need to do a stream where we just sit down and figure out how I'm going to do it. Because, like, I need to do some better animations. And I don't make any money doing this, so I can't afford to like pay somebody. I would love to just pay somebody to do it, but that's not realistic for me. So I gotta figure out that somehow. All right, that being said, I'm done for tonight. Let's find somebody to raid. Wait, what's gotten? I'm back on schedule. I should stream normal times now. Yep. So Tuesdays, Thursdays, Fridays, tomorrow at noon, lunch, we'll do the news, and then Saturdays. So we should be back on schedule now. We're going to have another break when I move again, but we should be back on schedule. Anybody see somebody that looks worth a rating? See you, Capability Snob. It was good seeing you. Thanks for hanging out. Sorry, everybody, my alerts aren't working. This person, one viewer, working on a tower defense game in Unreal Engine. I've never seen them before. Go say hi. Let the person know that there's some people that will see them work in their Unreal Engine. Unreal Engine's fun. Thank you everyone for joining. I hope to see you again in future streams. Maybe we'll actually code some in them, and I will see you guys tomorrow. Say hello to Ultimate Edition. I've never met them, but go check them out and say hi. It's the worst to stream to 0 people. I've done it a lot, so. And good morning to you all.